So hi everyone, my name is Jas Brooks, and today I'll be talking about changing the taste of real foods interactively. Now, this work I completed in collaboration with Noor, Amin, and my advisor Pedro Lopes at the University of Chicago. So let's dive into it. Here, a user is in VR and eats a food prop. In this case, blackberries. Later, they're going to actually be encountering other foods like a lemon. And while the user sees a lemon, in reality, they're picking up yet another blackberry. But what they taste is what they see, the lemon. How is that possible, right? This work is motivated by the growing interest in interactive food experiences, especially generating virtual tastes by delivering foodstuff to the tongue, but also modifying real taste through methods like electrical stimulation through utensils like chopsticks or forks. You may have seen this at the poster sessions, for example. Homemi Yoshida's work is fantastic on that front. However, altering taste perception, these kinds of techniques often do not allow a person to eat while experiencing changes in taste. So they're limited to changes before chewing and drinking, right? Oftentimes you have to take the fork or the chopsticks out of your mouth to be able to process the food that you're engaging with. We're left with a complicated problem, right? Our goal is to produce selective taste modifications while eating, which means we can address this problem with a solution using utensils or direct mechanical delivery of taste compounds into our mouth. Here we turn towards chemical stimulation, particularly using a class of compounds known as taste modulators. So let's get back to our user. Now, why would she think this blackberry would ever taste like a lemon? Let's rewind, and let me show you what happened before the lemon. Now, after the user is done eating that first blackberry, our device delivered a taste modulator into their mouth, here colored blue for visibility. These modulators selectively change our perception of basic tastes by temporarily altering the structure of our receptors, so that once you eat something else afterwards, it changes how it responds. Now, getting back to the lemon, right? Here we suppress the blackberry's sweetness with a compound called lactisole. This taste retargeted the flavor profile to something like a sour lemon flavor by accentuating the blackberry's sour notes. And you can apply this technique to turn one real food into many virtual foods. Here, for example, the user finds a strawberry bush, and we taste retarget to a strawberry taste by transforming the leftover sour notes into sweetness with a compound called miraculin. And we can go even further. By suppressing the rest of the taste, we can emphasize the bursting texture of the blackberry clusters to match the texture/slash flavor of a plump spider. We can then use other props, right? And the user can then encounter apples that change texture, or beverages that are retargeted based on their decisions. Ultimately, this allows us to retarget 3 real foods, these props, into 12 different and distinct virtual foods, a 4-fold increase in distinct flavor profiles. Now, we then conducted 2 user studies. In the first, we reviewed literature to identify taste modulators. We found 6 different ones: miraculin transforming sour into sweet, amiloride that can block saltiness, chlorfibric acid that blocks sweetness, gymnemic acids also blocking sweetness, lactisole doing a combination of sweetness and umami suppression, and zinc sulfate that can block both bitterness and sweetness. Then, to exemplify the power of taste retargeting, we ran a second study investigating the impact of taste retargeting on the use of food props in virtual reality. For this, we focused on the first food prop from our larger VR demo, the blackberry. For this study, unbeknownst to the participants, we delivered liquids before eating. In one case, water, and in the other, the modulators mixed into the water. So let's see how participants reacted, right? Of course, there's no difference between the virtual blackberry in VR. That's kind of reassuring. You would hope that this is the same for people. But then we start seeing differences. We start seeing sharp differences with the first retargeting. Like, wow, look at how it's already matching better the flavor of the lemon. And this trend continues throughout. Here we have to swap and go back to sweet. And finally, taste retargeting made the spider retargeting far more believable to participants. Some even rating it all the way at 7. And this is quite impressive because they're constantly eating the same set of blackberries from a plate. When rating how distinct the foods were amongst each other, taste retargeting made the virtual foods much more distinct in taste than in the baseline with no gustatory changes. Here, the closer it is to 0.33, the better it is. That means that they're more varied in flavor. And so you can see that we're already boosting this up quite a lot. Now, this exploration of taste retargeting to help food props in VR only represents one of the technique's possible applications. You can imagine in VR, of course. We can go further. We highlight 3 potential scenarios. First, interactive dining experiences. For instance, a multi-course dinner with an element of surprise, where diners use their smartphones to randomly pick a taste retargeting, yielding different experiences for each person to enjoy and bond over. Or taste retargeting can serve for recipe development. When making a new recipe, chefs and bakers have to produce each recipe variation, which is super labor intensive and messy. If you've ever been in the kitchen, you have to split those up and then cook them separately. It's really, really difficult. I speak from experience. So taste retargeting could help them produce a single test and preview different taste retargetings, like a rapid prototyping and design, but for food. And finally, one area that I'm especially excited to explore with this is dietary interventions. Imagine a user having something like a sugary soda, and instead of the usual intervention of a phone vibrating after you've drunk it already, my device or our device can provide a real-time dietary intervention, decreasing the sweetness and gustatory reward of the soda, helping guide the user towards reducing their intake in sweets. Let me conclude. Most existing taste-altering interfaces cannot selectively alter taste perception or only alter taste while the device is in contact with the tongue, so only before eating. Our goal today was to produce selective taste modifications while eating, which we achieve by using chemicals, specifically taste modulators. Taste modulators that selectively and temporarily alter our perception and have effects that last after delivery, allowing us to alter the taste of food during eating and drinking. Of course, there are limitations which we had to design around, which you can check in our paper. And I'm also excited about this work because it contributes to my overarching PhD topic. Today, I demonstrated that chemical selectivity can help us incorporate taste into digital experiences, and my prior work has explored smell, but also chemical stimulation for power-efficient thermal feedback. I refer to these class of devices as chemical interfaces, devices that manipulate the human senses by carefully delivering chemical compounds to the body. Finally, I want to take a second to thank my collaborator, Noor, Amin, and my advisor, Pedro, Lopes, for their support throughout this project. I will also be entering the job market next year, so any advice on that front is greatly appreciated. With that, thank you very much, and I'm happy to answer any questions.
Hey, I'm Arata from the University. Thanks for exciting talk. So I think the taste sensation is also will be affected by the texture or shape of the food itself. So for example, reproducing the sensation of chewing the spider, while eating the broccoli, how realistic was the sensation is?
So this is always the default question that I love to get after this talk when I was giving it before. I can say that we had a participant that had experience eating spiders and gave us feedback on this front, which shocked me. One, we did not select for that. And the response was that the taste was quite accurate, but the texture was backwards. So if anyone's doing texture stuff, I'll explain what they meant. A blackberry, when you eat it, it's gushy, right? It kind of like bursts in your mouth from the clusters on the front, and then it's crunchy at the core. Apparently the spider's the opposite. It's got a hard shell, and then it's gushy afterwards. But that's an exciting area to think about for future research, right? How do you actually achieve this taste change that's accurate alongside making the texture more engaging? So thank you.
Very exciting. Thank you.
Hi, I'm curious about Coca-Cola. Can you drink water but still feel sweet like Coca-Cola? So, people can control your weight?
That's a fantastic question. And it is kind of embedded a core, both limitation and affordance of taste retargeting in this case with these modulators. When you're doing taste retargeting, we're working with what's available, right, in the base food prop. So we can't necessarily take water and make it taste like wine or Coca-Cola or things like that, unless there are maybe trace amounts of those like compounds inside of it, like sweetness might be, like sweet water might be a good one to start with, maybe not too sweet. But you do have to have like components of each of the foods you're trying to target to be somewhat present in the food that you're working with. So that is a limitation, but the affordance is that you can go to a store and buy something that's already very complex and rich. Like Pedro on Monday was doing shopping for blackberries for our demo. But yeah, that's a great question. You would have to have some element of it already present.
Thank you.
Yeah, thank you.
Hi, great talk. Oh, my voice, sorry. Vivian from CMU. I'm just wondering, how long does it take for your taste buds to kind of reset to normal? And also, when I saw that you said that they were additive, but were there any that like interfered with each other or like maybe reverted back to the normal sensation or anything like that?
I love this question, yes. So the time one, this is definitely the limitation of like kind of chemical interventions in general. It's a longer period of time because you're trying to wait for the compound to unbind itself from the receptor or degrade. In our case, we were measuring things for like 10 minutes after delivery. Some of them were actually going back within that time period to default. No, 6 minutes, sorry. I'm thinking about two different things. So after 6 minutes, it came back. Some of them did last for longer. And that would be an exciting area to look for like compounds that would be able to unbind faster or have like a slider effect. And then could you repeat the second part of your question, Vivian? I'm sorry.
Did any of the effects like neutralize each other or make one like weaker?
Yeah, so we talk about this in the paper. To our knowledge, so no one's previously looked at like compounding these things together necessarily like we did in the paper previously. It's usually used in isolation, never in conjunction. And there's literature on that. So in our case, just from observation of people's experiences, there was no cross issues. So there's nothing that's like essentially fighting back or making the previous one disappear. That does mean that you're kind of like adding things if you're not waiting for it to go away. And then on the flip side, there is one that has like some potential cross effect, miraculin and lactisole, but we didn't notice that effect necessarily. It wasn't very strong or pronounced at all. Yeah.
Thank you.
Hi, Luke Kukowski from Accenture Labs. Really, really great talk. I enjoyed it a lot. I'm not sure what to call this, so I'll call it visual biasing. I'm curious if, so you're presenting a sour taste with a blackberry, for example, right? But sour can occur in a lemon, but it can also occur in a pickle, for example, right? I wonder if you looked at like the suggestibility of your participants. So as you introduce the sour taste and you present them with a lemon, do they think it tastes like a lemon just because they taste sour? Or is it truly lemon flavored as opposed to if you show them a pickle, would they also think it's a pickle?
Yeah. I think this is a really good question. My guess, and I think it still means it's powerful in that front still, right, is that in this case, because it's sour, people are associating it to the lemon. So without reproducing the smell aspects of a lemon, there is one participant that was talking about that they would get some floral notes, but they could still believe it because of the sour aspect. And there's a fantastic paper that was published earlier this year that was trying to like look at that suggestibility in conjunction with like inhaled odors. And they were saying that there was difficulties creating those like changes even then. So it seems like the gustatory aspect helps kind of like make that shift. In the case, at least for the paper, we do have the condition, the baseline condition, use VR with water. So we're measuring specifically for how much the modulator is adding to their ability to like map that in one direction or the other. I hope that answers your question. Yeah, thank you.
Thank you so much. Maybe the next question we can take after the session. Thanks so much, Jas. Really exciting work.
Thank you.
Great.